In our last class, we discussed cosine rule, sine rule, and also we discussed the concept of these two important rules. I am now starting for today. I'm starting the ambiguous case of the sine rule. So can you please give the heading ambiguous case, put the date of today and give the heading ambiguous case of sine rule.
Okay.
The ambiguous case is a case when we given two sides and the angle opposite one of these given sides. So this is called ambiguous case. Normally, ambiguous case comes in when there are two possible shapes of a triangle. Normally, it comes in a calculation way. So normally, in ambiguous case, the calculator or the calculation can create two answers. Look at this option. I have one triangle which has an angle 33. The other triangle also has an angle 33. The sides are the same, but you can see the shape is different. In the left-hand triangle, all the angles are acute. In the left-hand side, all angles are acute, but in the right-hand side, one angle is obtuse. So this is called ambiguous case. Acha, this occurs only in sine rule. I mean, its ambiguous case is not for other type of figures. It occurs only for, it occurs mainly, it occurs mainly for sine rule, and it happens during the calculation that there are, now this is one triangle, all angles are acute. Achha, now look here. Here, one angle is obtuse. One angle, let me mark here, A, B, C. Here it is, A, B, and C. So you can see here that you can see here in the screen that only one angle has become obtuse. Look, this one. So one angle, which is angle B, is obtuse. This is called ambiguous case. So after giving the heading, you have to copy this for your notes.
Okay. Okay.
Now, this is called an ambiguous case. Now, ambiguous case comes in when you are solving a, when you are solving when you're solving a triangle, and you find two possible answers, you have to look at the figure. Calculator sometimes can go to the right side, calculator can go sometimes to the left side. You have to remember that in that case, you can, what type of triangles can give you ambiguous case? Ambiguous case occurs when we are given two sides and the angle opposite one of these sides given. Now, this is a very technical concept that in the paper, how you identify that this is an ambiguous case. Look at this, two sides, 10 and 6. Okay, two sides, 10 and 6 are given. And can you notice that the angle which is given is facing one of them? Angle 33 is facing which side?
Um, the where
Angle
the
30, angle 33 is facing 6.
Mhm.
Angle 33 is facing 6. So this is important because all triangles are not going to generate ambiguous case. I repeat, when ambiguous case occur, when two sides are given and the angle which is given is not between the two sides. The angle which is given is facing one of the two sides. So now you have to copy this also.
Okay.
So this is the case. Now, can you repeat how you identify in the paper that this is a case of
When two sides and an angle opposite one of the given sides are ambiguous cases.
hmm. Now we move to cosine rule. You know very well from O level IG that what is this cosine rule. But as it is in our course, I have shared a worksheet with you. I have also shared the solution of that worksheet because it's a very easy worksheet, but obviously you can do some question, maybe two or three questions from it. To save the time for discussion, I have shared the working of it. This is cosine rule. Look at it orally. Can you recall it?
Mm-hmm. A squared plus a squared equals b squared plus c squared minus 2bc cos a.
Hmm. And this rule can be applied in this form also. Now, just take up your calculator and if you want to write it, you can, but you have to just do some solution trial with me.
Mm-hmm.
Okay, did you try
Sir,
this?
I got 81.8 degrees.
You got 80?
1.78 degrees.
Good. Now, let us summarize our discussion. When you are dealing with a triangle, this is coming mainly from IGCSE. When you're solving a triangle, there are two options: right angle triangle and non-right angle triangle. If you are if you're dealing with right angle triangle, you have Pythagoras theorem and you have the trigonometric ratios. If you are dealing with non-right angle triangle, you have a sine rule and you have a cosine rule. This is summary what we have done by now. Area of a triangle. There are two formulas. One is very famous, half into base into height. When we apply area is equal to half into base into height, we have to remember that base and height should always be perpendicular. Base and height should always be perpendicular. Now look at this formula. Area of a triangle, half BC sine A. Half BC sine A. Do you remember this formula?
Mm-hmm.
Good. So now you remember this formula. So let us quickly try a question for practice.
So I got 77.1 centimeters.
Good. That is perfect. Now, can you open that file, this one which I had shared with you?
Yeah.
And if you can open it on a parallel device, you can scroll it when it is needed. Chapter number 3, trigonometry, page number 48. If you can open the page number 48.
Mm. So which one?
Open the title trigonometry. I am looking for a question. This is question number 4. If you can open the question, if you want to solve on the PDF, if you have a tablet right now, so you can solve on it together. Otherwise, you have to look at this question and you can solve it. Just write down the question number.
Okay.
Okay. Now let's start the question. The structure consists of four wooden beam. AB is 6.5. AB is 6.5. BC is equal to BD is equal to 4. BC and BD are 4.7. BC 4.7 and BD is also 4.7. And angle BAC is 35. Find to 1 DP the size of angle ACB. This is ACB. So have you opened it on a parallel device so I can scroll it?
Yeah.
Good. So can you tell me that should I go? I have to solve part number A. I was thinking that in order to find the angle, I can select cosine rule 35, 4.7, 6.5. So
Okay.
angle C, I will start with 6.5 and I have, I can use sine rule and I can use cosine rule is better. Yes,
Yeah.
it's better to use it's not good looking to use cosine rule. It's better to use sine rule. Four point seven upon sine 4.7 upon sine 35 is equal to 6.5. So now let's try to solve it. Your calculator, make sure your calculator is always in degree mode because it's very important that other modes can create a big problem. So calculator should always be in degree mode. So now you have to solve this. Now look at this. Okay, did you get the answer?
I got 52.5. 489.
50,
2.489.
52.89.
489.
No, sorry, I missed it. 52 point.
489.
Okay, 489. Part B, find to the nearest meter the total length of wood required to make this structure. So, what's the meaning of total length? Look at the word he used here, total length. That word total length means perimeter. The word total length means actually here perimeter. So he want us to find, so you have to add up all the lengths. So how we can find it? Part number B. So can you give me a suggestion that if you read part number B, total length. Total length is equal to, what are the options here? AB plus BD. I have to add all of them. So I will write AB plus BD AB plus BD, and we have a CD and we have a AC also. AC, oh, acha, AC and CD. And we have a BC also. Acha, now what sides I have already? I have AB as 6.5. I have AB as 6.5 and BC and BD 4.7. BC and BD 4.7. And I don't have AC and I don't have CD. AC and CD is missing. So I need to find AC and I need to find CD. So please look at this working and let me know what to do now.
Um, we can find this. It doesn't say that BC cuts AD, so we can um I don't know, sir.
We have to use trigonometry now. Again, you know the trigonometry, the IGCSE one.
Mm-hmm.
So if I have this triangle, so can I use a sine rule or something like that? I have the angle now. So if I have the angle, I can use it to find the remaining sides.
Mm-hmm. Oh, yeah, you can. Okay.
So I get them here. I have,
Okay.
so now we are having this triangle. So I was thinking, I have the angle and we got the angle 52.5. Oh, this is another problem. How this angle is 52.5? It looks to be an ambiguous case. Look, this is an ambiguous case. Can you see this figure? It's a good example. It is an ambiguous case. You know why? Just look at the angle size in the diagram. It is not 52 point. It is an obtuse angle. Look at the shape
Mm-hmm.
of the triangle. And this is an example of an ambiguous case.
Okay.
Okay. So let's make our correction. This is an ambiguous case. And this angle is quite visible. If you look at the shape and size of the angle, it's quite visible that this angle is definitely not 52.5. It is actually an angle greater than that. This is called ambiguous case. And interestingly, we were discussing it right now, and we got a question of that. That's a good thing. Can you understand what I'm saying? If you see the shape, can you identify it? It's visible that it is not an angle of this angle is not 52.5.
Yeah, it looks too big to be
Yes, it
52.5.
looks too big. It's an obtuse angle. So once you get the answer, do one thing. This is an ambiguous case. So you tell the examiner that, look, this is an ambiguous case and subtract it from 180.
Okay.
So this is an ambiguous case. And now you have to do one thing here, that it is an ambiguous. So C is equal to 180 minus 52.5. Can you subtract it?
Yeah, it is 127.5.
100 and
27.5.
127.5. Good. This is an ambiguous case example, and this how we judge it, because we could see that this value is not possibly. It was quite clear to us that this value is not visible. It was clear that this cannot be a angle which is acute. Now this is the case. We have 127.5, 127.5. Now I'm waiting for you. Then how should I now find the AC? I can use.
Um,
I can find the third angle here, which
yeah,
is
that was it. What I'm doing right now. I found that angle and then I started using the sine rule to find it.
hmm, 127.5 plus 35. So what would be the third angle?
The third angle is 4.45.
Sorry, 12.5.
4.45.
Oh, I'm so sorry. Sometimes the voice totally bubbles out, no?
4.45.
4.45.
Yeah.
Okay. So now we can find AC upon sine 4.45 is equal to 4.7 upon sine 35. AC is equal to 4.7 upon sine 35 into sine 4.48. This is AC. Now try to find AC.
So
One
how
more
will I find
side. Hmm,
CD? How will
how
I
much?
find D?
Sorry,
How will I find CD?
sine.
How will I find CD?
Huh, that's a good point. So this is what I was asking. That I was thinking that we can. Why do I was thinking now that why don't
Oh,
we?
sir.
Hmm,
I thought when you said what was the answer for CB, I thought you meant what was the answer for AC. AC is 4.45 centimeters, not um
okay. So you're getting 4.45 is the answer for AC. It's not the angle.
yeah, yeah,
Acha, what is the third? What was the third angle then?
25.5.
Okay, 25.5, and you got it here. Acha, now I got the AC.
So yours is different to mine.
Hmm?
The question is different to mine.
Which one?
It's going to be different angle numbers.
Different angle numbers.
Yeah, I have 27 degrees, you have 35.
4.7
Okay,
upon sine.
I have 35. I have 27 instead of 35 degrees. Let me do it again.
27 instead. But 35 was given in the question.
But I did not, my paper has 27. Okay, I'll just do it again. The
Do it again.
the answer for the angle ABC is 17.5 degrees, and then um, okay, I am getting a different answer. I get 2.464.
Uh, so you're getting a different answer now?
Yeah.
For which part? For which side?
For AC.
Okay. So let me check also. I lost the screen. I'm trying to get back.
Mm-hmm.
Okay. So, acha, now can you repeat what is the new number now? Are you getting a different answer for AC now?
Yeah, I'm getting 2.464.
2 point. It's looking so small. Acha, angle. What about the angle B?
Angle B, I got 17.5.
So angle B is also different.
Yeah.
Acha.
Oh, angle B, yeah, angle B is different, yeah.
Okay. Acha, what you got for angle B now? 17 point.
5.
Okay. If we put 17.5 here, 17.5. Acha, now what is the value of AC you are getting?
AC, I'm getting 2.464.
2.42.
464.
464. Okay. Now I was thinking if we subtract 127.5, we can get the inner angle there. We have two sides, 4.7, 4.7. My next target is CD.
Mm-hmm.
I got now AC. My next target is CD.
Mm-hmm.
Now, can you subtract can you subtract 180 from 127.5?
Okay. 52.5.
52.5. This side and this side are equal. So this will also be 52.5. It's an isosceles triangle. Na?
Mm-hmm.
BCD is isosceles. So BCD is, okay, this is isosceles BCD.
Mm-hmm.
Okay, I'm waiting for you now. Can I find the third angle, angle B, angle CBD? Angle
Yes.
CBD will be equal to, I have 252.5 because of this. So 180 minus 52.5 into 2. Okay, now can you find this angle?
Yes. 75.
75 degree. Okay. My third angle, as you found here, this angle is 75. Okay, now I have a good position. Now I can find CD. How can I find CD? I have now sine rule. I can use sine rule also.
Yeah, the
I
sine
can
rule.
use
So
CD.
4.7 over
Mm,
sine 52.5 equals to x over sine over 75.
yes. CD upon sine 75 is equal to CD upon sine 75 is equal to 4.7 upon 52.5.
Mm-hmm.
4.7 upon sine 52.5. If you find CD, it will be 4.7 upon sine 52.5 into sine 75. So see what CD comes in.
CD, I got 5.7.
How much?
5.7.
5.7. Okay. So let us say that this was my total length equation and this was equation 1. So now if you put all the values in equation 1, you can find the length 6.5 plus 4.7 plus 2.464 plus 5.7 plus 4.7.
So I got 24.064.
Can you repeat the number, please, for the length?
24.064.
24.06. Okay. Now, can you join question number 7?
Mhm. Okay.
Okay. Now look at this question. Show that p square plus q square minus pq is equal to 8. So now we are moving towards this. So should we start by using cosine rule? Do you think that?
Yeah. Yeah.
Okay. So let's start part number A. I'm starting with cosine rule. A square is equal to B square plus C square minus 2BC cos A.
Mhm.
Now, I was thinking that if I can start with 2 under root 2, I can start with 2 under root
Yeah.
with a square on it. And I'm facing P and Q. So I will write P square plus Q square minus 2PQ cos 60.
Cos 60 is a half.
Hmm.
Cos 60 is half.
Cos 60 is 1 upon 2.
Yeah.
So we can cancel the 2. 4 into 2 is 8. P square plus Q square minus PQ. So this is the first part. We have proved that. Now, how we can solve part B?
Um, AC is 2 meters longer. We could do um we can replace Q with P plus 2.
Hmm. So the exact value of P, are you saying that AC is 2 meter longer than AB? So if AC is 2 meter, AC is 2 meter longer than AB, AB is P. So should we say that Q is equal to P plus 2?
Mm-hmm.
B
Yeah.
part 1. B part 1, and it is 2 meter longer than AB. So it is 2 meter longer. So Q is equal to P plus 2. Q is equal to P plus 2. The exact value of Q. So should I think about solving these two equations? If I have this equation, I have
Yeah,
P square. Okay.
yeah,
I have P square plus Q square minus PQ is equal to 8. So in place of Q, I can put P plus 2. So P square plus P plus 2 whole square minus P into P plus 2 is equal to 8. He wants exact value, so we have to avoid any decimal control. Now, what should I do after that?
um, you should expand.
So should we open the formula like P square plus P square plus 4P plus 4 minus P square minus 2P minus 8 is equal to 0. I'm getting this equation. You can tell me what
Yes,
you are getting.
I'm getting that as well.
So what do you think now? What should we do? Okay. Now this is the equation. P square plus P square will become 2P square 4P and minus 2P. 4P minus 2P will be 4P minus 2P is 2P.
Mm-hmm.
And oh, there is some error I'm doing. Actually, 1P square is cancelling, interestingly.
Yeah.
Did you solve it? Because I'm getting 1P.
Yeah, I solved it.
You got the value, you got the equation.
Yeah.
Acha,
I got p squared plus 2p minus 4, and the solutions are minus 1 plus minus root 5.
hmm. Then it means 1P square will cancel out.
Yeah.
Okay, 1P square cancelled out. So P square plus 2P, P square plus 2P and minus 4.
Mm-hmm.
So did you solve this equation?
Yes.
But I'm not getting the same numbers. What values of P you are getting?
p minus 1 plus root 5 and minus 1 minus root 5.
Okay. And in that way, what is the value of what value of P you are getting? Oh, sorry, what value of Q you are getting?
Minus 1 plus root 5 and minus 1 minus root 5.
No, but you have to give the answer in exact form, na? No, no decimal.
Oh, okay. 1 second. I am getting 1.236.
No, but you're giving
And
decimal. You're not supposed to give decimal.
then,
You have to give the answer as a fraction or whole number. Do not give decimal.
okay, minus 3 and 1.
And minus 3 and 1. Then he says, calculate the exact area of the flower bed. If we know the P, if we know the Q, how we would be able to find the area of the triangle?
Hmm?
Look at the last part of the question, part C. Calculate the exact area.
Yeah. Um, we can substitute in the equation in the numbers, and
Mm,
then we can put the half AB sin C rule.
Yes, half AB sine C rule, right? Half AB sine C. So in that way, we can solve this triangle. So that's good. So we are done with it. And this topic, we need trigonometry is going on, but we have done the basic trigonometry. What I had asked you to do, look, this is the book, huh? In this
Mhm.
book, we have done chapter number 1, we have done chapter number 2, and algebra and graphs are not complete. I know some graphs are still remaining. Right now, we are doing chapter number 3. You have a worksheet to finish. So, just like you did already some questions from algebra and graph. So, what I need you to complete chapter 1 and 2 from this PDF because November has started. If they are going to give you a mock on 17th, definitely these chapters are going to come. Chapter 3, because already chapter 3 is there. So I'm sure they are going to give it. So let's stop here, but please do try to complete chapter 1, 2 from the PDF.
Okay.
Okay, so we are stopping here. We'll inshallah continue in our next class. Allah
Allah
Hafiz.
Hafiz.